Welcome to the third part of the series. Today we will learn how to use Neurokit to detect RPICs in an ECG signal. But before we do that, I wanted us to talk about the issue that we had in our previous video. Here in the graph, you can see that one heartbeat has two RPICs. And the reason for that is I actually made a mistake and I did not add the condition with the minimal distance threshold. So here we check the current sample if it's bigger than the previous sample, and then if the current sample is bigger than the next sample, and then whether this sample is bigger than the threshold. So to fix the minimal distance threshold issue, we just need to write a couple of words. It's very simple. We had an and, another condition, not peaks, or minus peaks minus 1 more or equals minimal distance. So this condition will check whether this list is empty or not, and this will check whether current sample minus previous sample, which will equal to the distance between them, is more than the threshold that we specified earlier. If it meets this condition, these four conditions, it will have our RPIC saved in the list. So why do we need this one? Is when we have our first loop and we get through these three conditions, and then we get to this one, we need to check the distance between the current sample and the previous sample, which is impossible because we have not appended anything yet to this list. So it will skip this condition and then append the RPIC according to these three rules. Now, during the second loop, we will already have one sample or RPIC saved in the list, so it will be able to measure the distance between the current RPIC in the second loop and the first RPIC detected, and we'll do it again and again and again and prevent two RPICs being too close to each other. So let's run the code and try it again. Okay, yeah, it has fixed the issue. Yeah, this is it for the fix, and now we can move to our Neurokit library. With Neurokit, it's pretty simple. You do not need to write all this code to detect your RPICs, but I think it's still important to learn how to do this manually, because if you just use the library, you won't really understand how it's done. So this step is also very important. Now we can open the documentation, which is in the section of ECG RPICs. So this is the function that we need to pass it our signal, specify the sampling rate and the method. Here is an example. So here they generate a synthetic signal and they add some noise, which is here, and then they use their function to detect the RPIC. So we just need this part. Here we have two variables, signals and info. Signals is a data frame of some length of same length as the input signal, in which occurrences of RPICs marked as 1 in a list of zeros with the same length as your signal, accessible with the key ECG RPICs. Info is a dictionary containing additional information, in this case the samples at which RPICs occur. That means that on the x-axis, it tells us at what point of time a certain RPIC occurs. So it can give us the indices of these RPICs. So this is what we need. So first we change the sampling rate, it's 100 for us. And then I'll call the function and store the RPICs indices in my RPICs list. So we use info, which stores the indices of the RPICs, and we use the key, which is ECG RPICs. Yeah, here we have our R peaks, and now we can plot the signal and see the R peaks detected. With Neurokit, it's very simple. You just type one line of code, plt.show. Yeah, as you can see, it works pretty well, and it's very simple. But keep in mind that sometimes the signal is really noisy, or some data is very abnormal for some patients, and in cases like that, Neurokit will still fail to detect your R peaks or Q or S peaks. So just keep that in mind, that you always check your data. Um, this is it for this video. Thank you for watching, and I'll see you next time. Bye.